So for the final section of Chapter 2, we are now going to get into solving inequalities. So in the last lesson, we just did solving rational expressions. So in this one, we're now just diving into the last idea, which is solving inequalities. This one should be new to you. We are going to break this up into two parts. So for part one here, let's get rolling. So use a sign chart to determine where the function is 0, positive, negative, and then we'll verify it on a graphing calculator. So here's the idea. When you solve inequalities, you are not looking anymore for zeros or specific points as answers. You are looking for a range of answers because it's no longer something that equals x, it's something that is greater than or less than. So we're looking for whole areas of the graph to identify. So all this starts with finding our super key points, which is just identifying the zeros. So as we look at this, my zeros, as I can see, would be -3, based on that one. Sorry, let me slide that back down. -3 from the first guy. Remember, we're getting this by setting each factor equal to 0. As I set this equal to 0, so x squared equals -1, I would go to square root that, and you can't do that. So I'm not going to get any zeros out of him, but from right here, I'm going to get +4. Remember, one thing I'm expecting when I graph this is, because this is an odd exponent, this is a first power, I expect the graph to cross over -3. When I graph this one, I expect it to bounce off +4 because of the even power. So we'll look at that in a minute. So those are my two zeros. So when they say use a sign chart or a sign graph, they're just saying identify your key points. So let's just say -3, and we'll just put it right here, +4. Those are my two key points. So there are three main areas of the graph. I have to the left of -3, between -3 and 4, and then to the right of 4. Those are the three areas of the graph that we have to determine whether they are positive or negative. So here is one approach that we can use, and I'm going to show you how we can take advantage of a graph as well. In fact, just knowing what this graph should already look like, we should be able to even just sketch the graph and identify where it's positive and negative, just by looking at where it's above the x-axis and where it's below the x-axis. As far as these go, so we're going to identify our three main intervals. So to the left of -3, we would call that from -infinity to -3. And then right here, we're between -3 and 4. And then over here, we are to the right of 4. So those are the three areas of the graph that we have to determine whether they are positive or negative. So what we're going to do is test some signs here. So we're going to look at each factor at a time, and then we'll look at the overall result. So if I were to pick a number anywhere over here, so anything from -infinity to -3, such as -4, plug it in for x, I would get a negative result. If I pick any number, say same number, -4, and put it into this factor, I'm going to square it and then make it positive, and it would have to come out to be a positive. All right, -4 squared is +16 plus 1. And if I put it into the third factor, again, if I use -4 minus 4 is -8, squared becomes a positive. So here's why we're doing that. If you go back up to these, this is all multiplication, right? This times this times this. So if I have a negative times a positive times a positive, overall, that area of the graph is negative. And so we're going to identify this as a negative section of the graph. It's below the x-axis. Let's do these last two. So any number between -3 and 4, such as 0. 0 plus 3 is positive. 0 squared plus 1 is positive. We should already recognize that these columns This one and this one will always be positive because of the squared that's going on in there. So for this section of the graph, a positive times a positive times a positive is overall positive. So we know that section of the graph is above the x-axis. And the very last piece to the right of 4, if I pick a number like 5 and plug it in, 5 plus 3 is positive. 25 plus 1 is positive. 5 minus 4 squared is positive. So again, that section's overall positive as well. So here's what I want you to recognize. A lot of this you probably should have figured out or could have figured out just by thinking of what this graph would look like. If I consider a real simple sketch here, real simple, I know overall this is x to the first, x to the second, x to the second again. If I combine all that, I'm looking at an x to the fifth graph. Because it is a positive x to the fifth graph, I know that my end behaviors should be opposite of each other. Since it's positive, this side is going up, which means this side must be downward. So if I was just going to sort of do a very rough sketch, I would do something like this. I know it's going to go like this. It's going to bounce, as we already talked about, off my 4 and go back up. So it's going to do something like this. Just based on that graph, I can see that this is below the x-axis, so that's why that area is negative. And the other two areas, here and here, are both above the x-axis. So I already know those are positive. So realistically, if I could even sketch a graph based on what we already know, I could determine where the pluses and minuses should go without even having to do this whole chart. So that's always good to be able to do. We can graph it in here. I just threw it in real quick. I don't have a very good window here, but you get the idea, right? It's negative, and then the rest of it's positive. So that one's a little prettier than what's on my calculator. So let's identify the areas of the graph that are greater than 0 and the areas that are less than 0. So as we look at these, we can see that this interval was overall negative, so greater than 0 would be those two. So right here I have my negative infinity to negative 3. That's the one that was less than 0. And then these two intervals from negative 3 to 4, along with 4 to infinity, are greater than 0. Keep in mind, there will be times where we use parentheses. There will be times where we use brackets too. You're going to have to look careful. If this said greater than or equal to 0, that would change things, right? Then I want to include the negative 3 and the 4. So that would change things if we did that. So that's something we're always on the lookout for. So here's the main idea. When you're solving equations, it's no longer going to say equals. It will say either greater than or less than or greater than or equal to or less than or equal to. And so what we're looking for is which intervals would fit that description. So that's kind of the overall goal here. A little side note, if you need to break it down first, the one that we just did was already factored for us, and that really helps. If it was not factored for us, we've been learning this whole chapter on how to find the zeros of a function, right? We got synthetic division, we got looking for x-intercepts on the graphing calculator, all that fun stuff. So we have those methods already, and that's why we've been learning all that this chapter. It's all been leading up to this exciting section of graphing. All right. Let's go for the full-blown process here. So, for this one, first things first, if they give you something that is not compared to 0, you have to do that first. I need everything on one side, and I want my leading term positive. So this is x to the third. is less than or equal to 3x plus 1, I want to subtract these over to the other side. So it's going to say x to the third minus 3x minus 1 is less than or equal to 0. That's the function we want to work with. You wouldn't do anything without doing that first. This one, if it's not factorable or if we can't find the zeros, or this one is obviously a little different because it's a cubic power, we may have to find the zeros simply by using our graphing calculator. So this one was intended to be solved graphically, right? So that's why they gave us something that we wouldn't be able to factor and find the zeros for. So this one would just be done on the graphing calculator, and I will do that with this one here in case you don't remember. So as I look at this, so we found the zeros, and then if you go back to the original function, it looks something like this. So we compared it to 0. So ultimately what they're asking for is which sections of this function are less than or equal to 0. So I am looking for the negative sections of the graph. This one did come with an equal sign, so we got to remember to use brackets when we do this one. So here is a negative section of the graph because it's below the x-axis. From this 0 to this 0 is also negative. So those are the two sections of the graph that we would state as our answer. And that's what they did right there. Notice the use of brackets because of the equal sign. So let's do one of those together. We're just going to do this like pure calculator style, and then we'll do some more fun stuff down here. So first things first, x to the third, let's bring these guys over. So we're going to see this as x to the third minus 3x plus 2 is greater than or equal to 0. So we are now looking for the positive sections of the graph. So let's throw that all into here. So x to the third minus 3x plus 2. Let's graph. Should see an S shape. And there we go. So just in looking at that, I can see that my positive sections of the graph are really everything to the right of what looks like negative 2. Let's just confirm what that is. So if I go under calc, choose 0, they're going to ask me those boundary questions. I got to be to the left of it and hit enter. Then I need to be to the right of it and hit enter. And then hit enter one more time, and sure enough, it is at negative 2 exactly. So I can see that this is my negative section. The rest of it is positive, except for this, which is a 0. So here's kind of a key piece of info here. If there was no equal sign, meaning I cannot include that 0, and it looks like positive 1, but if I cannot include it, I have to write this as one section, and then I would need to write this as a separate part of my answer. So I would say something like from negative 2 to positive 1 with parentheses, and then from positive 1 to infinity with parentheses, if there was no equal sign. This one has an equal sign, which means we can include the 0. So as far as the things that are greater than or equal to 0, I can just say it's everything to the right of negative 2. So for this one, we can just say it goes from negative 2 to infinity as my answer. And again, I'm throwing in the bracket because of the equal sign. It is 0 at negative 2. So that's how we could do it with sort of just calculator alone. And I already know what you're thinking. Why can't we just always use the calculator? I know. It's more fun this way. You're going to learn some of this by hand too. All right. So at the start of this video, we looked at making a sign chart or a sign graph with like a number line. In order to do that, you have to start by finding all of your key numbers. Key numbers are not just intercepts, simply because what we're really looking for here is changes in sign, right? I want sign changes. Intercepts can create sign changes, but so can vertical asymptotes, and so can holes in the graph. All those things can create sign changes in your graph. So all of those can be key numbers. So if you look at this, you see on this one how 0 and positive 3 are my vertical asymptotes. So we are using 0 and positive 3 as two of our key numbers. As far as this guy, remember how we find x-intercepts, right? To find x-intercepts, we plug in a 0 for y. If you multiply this over, it's still 0, so 0 equals 2x plus 3. If you solve that, you get negative 3 over 2. So our x-intercept is at negative 3 over 2. So those are all the key numbers. There were no holes in this graph. Holes come from removable discontinuity. If you can cross out common factors, those are holes instead of asymptotes. But we didn't have any of those for this one. But that's what we're looking for. So those are the key numbers. From here, we would simply test some numbers to find out which sections of the graph are positive and negative. So if I took a number over here, like let's just say negative 2, and if I plug it in for x, is my overall positive or negative? So if I put a negative 2 in here, so let's see, that would be negative 4 plus 3 is negative 1. And if I put it down below, negative 2 times negative 2 minus 3, so negative 5 times negative 2, that's going to be a positive. So if I have a negative divided by a positive, then this is an overall negative section of the graph. So by testing numbers within these intervals, we can determine whether it's positive or negative. Take a number like negative 1. If you put negative 1 into this, so negative 2 plus 3 is positive on top. Negative 1 times negative 1 minus 3, so negative times a negative is positive. So a positive over a positive is overall positive. I don't even need to know the answer. I mean, I plugged in negative 1. I don't really need to know the result of negative 1. I just need to know if the result is positive or negative. So I'm really just checking the signs to see if I'm going to end up with a positive number or a negative number. Plug in a number like 1. So 2 plus 3 is a positive on top. 1 times 1 minus 3 would be a negative on bottom. So overall, a positive divided by a negative is negative. Let's test 4. So 8 plus 3 is positive 11. 4 times 4 minus 3 is a positive result. Positive over positive is positive. So those would be the main areas of the graph. And now if it says, instead of an equal sign, if it said greater than, I could be picking these intervals for my answer. If it said less than, I would be using those intervals for my answer. So that sign chart tells us what the interval answers are. So if you took a look at this graph, it looks something like this. So it does fit our sign chart. So here is negative 3 over 2, and this is a little hard to see. If you zoom in on it, you could see that this is below the x-axis, so it's negative. This is obviously positive, negative, positive. So just like we came out with in our sign chart. Let me flip this guy over. One more. So I wanted us to kind of try one from scratch here. So if we look at this, so this first half of section 2.8 is mainly about just identifying the key numbers, identifying the positive and negative sections of the graph, so that in part 2 video, we can kind of put all that together and then go on to solve questions like this. So we're really doing the legwork in this first part. So first things first, we got to find the key numbers. Let's check vertical asymptotes. If I set my denominator equal to 0, we can see that positive and negative 2 would be our vertical asymptotes. So those count as potential sign changes. Also, if I set the y value equal to 0, so 0 equals x plus 1, I'm going to get negative 1 as my x-intercept. So we're looking at negative 2, negative 1, positive 2 are the areas of the graph that have potential sign changes. So we're going to do this. We're kind of doing all this without calculator help for now. So if we sort of break this down into the 4 sections of the graph, we got this guy right here, which goes from negative infinity to negative 2. From negative 2 to negative 1. From negative 1 to 2. And 2 to infinity. So those are the 4 sections of the graph. We got to determine whether they are positive or negative. So what we are looking at are the 3 factors that created this, right? Because on bottom it's really x plus 2, x minus 2. So I got this factor on top, I have this factor on bottom, so I'm breaking it down between those 3 things. Remember, this is all division and multiplication. So if I have an odd number of negatives, it should be an overall negative. If I have an even number of negatives or no negatives, we know the result's positive. So if we took a number like negative 3, plugged it in, so negative 3 plus 1 is a negative, negative 3 plus 2 is still negative, negative 3 minus 2 is still negative, odd number of negatives, we know that section of the graph is overall negative. So do the same thing for this. So using this chart is just a way of sort of breaking it down step by step and trying to do it all in your head, kind of like what I did on the previous example. Pick a number in here. So this one a little trickier. We got to use something like negative 1.5. So if we did negative 1.5 plus 1, negative 1.5 plus 2, and minus 2, so we have an even number of negatives, so that area of the graph is positive. Let's take a number like 0. So 0 plus 1, 0 plus 2, 0 minus 2, so we can see that overall is negative. Last one, plug a 3 in there, so 3 plus 1, 3 plus 2, 3 minus 2, and we're looking at a positive section of the graph. So we've now identified what sections of the graph are positive or negative. Let's just write those out and then we will call it a day for this one. So the zeros, we really only had one 0. The other one were asymptotes. So we want to keep in mind, and this is really important as we get into the final lesson in the next video, when you look at these key numbers, you do need to keep in mind which of those were intercepts and which were asymptotes. Simply because if we start getting something like greater than or equal to, and I'm supposed to include the zeros, I need to know if these are a 0 or if it's an asymptote, because that'll make an impact on the way we write our answer. And we'll see some of that within the next video. So for now, let's just keep in mind that this negative 1 was our 0, and these guys were asymptotes. So really, these were sections of the graph that were undefined. So that will definitely factor into the way we write our answer in the next part. So it's good to recognize those. So the 0 on this was at negative 1. The undefined values were the negative 2 and the positive 2. So intervals where this was positive, we can see the plus signs right there. So from -2 to -1 is a positive section of the graph, as well as 2 to infinity. Negative sections would be these two. So from -infinity to -2, along with -1 to +2. So that's kind of all the legwork for all of this. We'll then be using all of this in the final lesson next time to go on to actually solve these type of inequalities. So, but that is it for this one.